When a female mountain pine beetle like the one in the bucket lands on a tree, she first has to decide whether it's a decent place to raise a family. To do this, she'll chew into the bark and taste the chemicals. If the tree meets her standards, she'll continue burrowing. Severing ducts that contain resin. The tree's first line of defense. Ideally for the tree, the resin will simply flush the beetle out. But evolution is all about one-upmanship. And in a particularly elegant flourish, the beetle has evolved to ingest the resin. If she can survive swimming through the syrupy river and convert it into a pheromone, a chemical that sends a message to other beetles. By releasing this pheromone into the air, the beetle signals that she's found a great place to congregate. Other beetles, male and female, gather. If there are enough of them, a mass assault ensues. The tree doesn't give up easily. As soon as the burrowing beetles reach living cells, the cells commit suicide. As they die, they rupture, releasing a substance that's super toxic and beetle annihilating. If there aren't a lot of beetles, says Carol, generally the tree wins. But if the beetles invade with an army, not just a few scraggly mercenaries, they overwhelm the tree. Depending on the tree's condition, it can take many thousands or just a few hundred beetles to kill it. The drought and warmer temperatures that have struck western forests in recent years have helped the beetles in two ways. By stressing the trees so much that they succumb more readily, and by giving the beetles more time to attack them. Beetles in Montana, says 6, used to fly from one tree to another mainly during 2 weeks in July. But now, as that infested tree in the Big Hole Valley shows, the flying season lasts into October. That means the beetles have additional time to reproduce. Even as the extreme cold snaps of fall and spring, which help to keep populations in check, have become rare. There's an airy wisdom in a beetle mob. Sparsely distributed beetles besiege small trees. Denser groups go for larger quarry. They seem to attack a larger tree only when they know there are enough of them to take it. How does the first beetle know? Carroll and his graduate student Jordan Burke suspect it's the pheromone. A burrowing beetle releases it to call for help. But the amount that's in the air already tells her whether help is available and it's safe to lay her eggs. The beetles in Carol's office is a part of an experiment testing that hypothesis. In any case, the cycle feeds on itself. The bigger the tree, the more beetle babies a beetle mom produces. More beetles mean more mass attacks on bigger, healthier trees. Once there are enough beetles to blast larger trees, larger swathes of forest are essentially doomed. In 2013, scientists at the University of British Columbia sequenced the mountain pine beetle's genome, making it only the second of more than 400,000 beetle species to bear that distinction. The first was the red flower beetle, which infests stored grains. But Georg Bowman, the plant biochemist who oversaw the sequencing effort, doesn't think a biotechnical fix to the pine beetle epidemic is imminent. Colorado. Spruce beetles and fire have killed almost every tree near Wolf Creek Pass. The pine beetle epidemic has peaked in Colorado, but attacks by spruce beetles, which also burrow through bark, are still on the rise. Chronology of an epidemic. Historically, the mountain pine beetle's primary host has been lodgepole pine in the north, where lodgepoles dominate the landscape. Cold temperatures help to keep beetle populations in check. Down south, the insects had far fewer trees to infest. With forests increasingly warmed by climate change, the beetles are thriving in once inhospitable areas, attacking species of pine they rarely touched before, and drastically altering the landscape. The beetle and its host, mountain pine beetle occurrence, red, blue lodgepole pine ranges, bright yellow-green jack pine range, almost yellow other pine species. 1990-1996, prelude to disaster. A potential epidemic in the mid-1980s was averted by two particularly cold winters in a row, but by the mid-1990s, a combination of forestry policies, warmer winters, and dry summers had helped beetle numbers rise dramatically. Infestations erupted in pockets across the drought-stricken British Columbia, Washington, and Oregon, sowing the seeds of an epidemic. 1997 to 2006, the epidemic begins. Beetle populations swelled to unprecedented numbers as their range expanded north and east. By 2006, beetles had crossed the Canadian Rockies and were in the area around the Grand Prairie, Alberta. By 2007, the epidemic in British Columbia was slowing as the beetles ran out of trees to attack, but from Montana to Colorado it was nearing its peak. 2007 to 2013. Into the jack pine. The beetles advanced into formerly unhospitable zones where winter temperatures are no longer reliably cold enough to kill them. They also colonized the jack pines, a species found across Canada's boreal forest. If the beetles can sustain a population there, they could eventually spread east across the country and down into the Midwest and New England. Northern Alberta, where jack and lodgepole pines both thrive, is now the front line in the beetle battle. Alberta's aggressive cutting and burning of trees may slow the beetles' eastward spread. Southernmost occurrence of lodgepole pine. Few species of pine are immune to the mountain pine beetle. Some scientists fear that winds all infested wood might even spread it to the white, low-broadleaf and longleaf pine of the southeast.